Hi, my name is Calvin, and welcome to my COMP3122 Assignment 3 on Applied Data Science in Python. So, for this assignment, we're going to be working with data frames, specifically pandas, using this test.csv file. So, what I will be doing is I will be walking you through all the commands used, what they're used for, how they're used, and kind of what I learned, and just talking about some of the fun bits throughout the assignment. So first things first, we're going to want to download this test.csv file and upload it into Colab. Remember that all uploaded files are deleted after you close the tab, so just make sure that you upload it back into here before you try and run your project. Otherwise you'll get a couple errors and it will not be a fun time. So the first things first, we're going to want to import pandas as PD. We're actually going to be using pandas for pretty much every single command, so this is probably the most important line in the entire assignment. Next thing, we want to store our test.csv file inside of a data frame, and we're doing that inside of our variable mydf. So we're using pandas and we're reading the CSV file and we're storing it just inside of our variable. And the next thing we're going to want to do is we're going to want to take our data frame, now stored in variable mydf, and we're going to want to show the first 5 columns of the data frame. So as you can see, these are actually our first 6 columns of the data frame. This is actually the very first row in our data frame right here. However, since we don't have any head, it prints out like that, really awkward, really ugly. This not a number line is actually not supposed to be a row. It's not supposed to be a column. That is actually supposed to be the zip code. However, we don't have any headers or column IDs, so it just formats very ugly and the program kind of doesn't really know what to do. And so we're going to go and fix that. Question number 3, we're wanting to add names to the columns. So we're going to label them ID, range, value, machine type, and zip code. And we're going to take our data frame variable. We're going to read that test file. We're going to say we have no headers in there because, as you remember, it is all just the data as shown above. And we're going to want to change this header names to all of these inside of our list right here, as I said, being ID, range, value, machine type, and zip code. And then, if you don't believe me, I'm just going to display the first couple rows inside of our data frame. As you can see here, you can just ignore that very first line with my name and student ID. It's actually used for the next question. So let's just zip on over to there. So we're reading our CSV file, but before we do that, we actually edited the CSV file to add our name and our student number up at the top. So that's why you can see now, when we read it, we have as our IDs, we have my name, my student number, and these 3 unnames. So the 3 unnames are actually added automatically because I did not put enough data in order for them to be named. So what the program did was say, hey, you're missing a couple column names. We're just going to put unnamed in the row number for however X amount of rows there are remaining. So in this case, 2, 3, and 4, but it could go all the way up to row 100, 1,000, so on and so forth. Next, we're going to want to skip that row with my name and ID. I know, as interesting as it is no longer relevant to the rest of the program, and it is no longer relevant to the data that we need to be getting from the CSV file. And so we're going to say skip row number 1, which is just this row right here with my name, ID, and a whole bunch of unnames. And we're going to display it again. And as you can see, we got this ugly kind of data frame again without the column IDs, out the headers, all of that good stuff. And now I'm going to show you just the type, just to make sure we're working with data frames. That's just our variable where we're storing our CSV file. If you remember, that variable reads the CSV file, and that stores the data frame inside of the mydf variable. And then next, this is actually just the exact same code from question number 3, but I just wanted to reset my mydf variable and just have everything nice and pretty with all the column names because you are going to need it further on into the program. And once again, skip row number 1 with just my name and ID because that value is not necessary. And now we're going to go on to question number 7, and we're going to show you a couple different ways to select some of the Panda columns. First one, really readable, really simple. You take your variable and you store whatever column name you want inside of the square brackets, and it'll textually output all of those values inside of this case, the value column. Next, which is a more object-oriented approach or object-oriented style, it will go, we're going to take our data frame and we're going to search for everything, which is what the colon says. We're going to take everything from the data frame and we're going to display everything that is in the value column. There we go. Couldn't think of column for a second. And basically, it shows inside of our nice tabular output, nice and legible. We can see everything from the value column. If we put like zip code, for example, as that column, it would show everything from the zip code column because of that colon right there telling it to get everything. And we'll continue to question number 8. We can see what is the type of the selected column. As you can see, every column inside of our data frame and inside of Panda's data frames is actually of data type series, and that just makes it so that we can work around and play with it, as I will show you further on in this assignment. So question 9 is, once again, I told you we could do the same thing with zip code. Well, now I'm going to show you, once again, same thing as zip code. Both work. I personally prefer the top one just for easiness. It's easier to remember, easier to write. However, the bottom one right here is easier from an output understanding point of view. So ultimately, it just comes down to personal preference and what one works for you the best. And continuing on, we're going to go to question 10, and we're creating our very own column or series, and we're going to be giving it the name brand. And what we're doing is we're taking the machine type column and we're taking the zip code column. So we're going to take the data from those columns and we're going to combine them into our very own column, brand. And as you can see here, we're going to output brand. And as you can see, the very first letter, in this case F, is actually the machine type, followed by the zip code NXEYEM, and so on and so forth for the entire data frame. Question number 11, we're doing a similar thing. We're actually going to create another series or column inside of our data frame called total, and we're taking our range and we're multiplying it by the value. And once again, we're going to output our total. It's coming out as a float because both those numbers are actually stored as float values if we forgot. So we're going to go down to question 12, and we're going to just show you a couple of the data frame commands and kind of how they work. So as you can see over here, we have the head command. The default shows the first 5 rows. However, you can type in any number here and it'll show you however many rows based on that number that you typed. As you can see, we added that brand and that total to our data frame series, so they're printing out just at the end there. And like I said, if you scroll up, we'll just use the total for this case, but if you scroll up, you can see that is the machine type followed by the zip code for the brand, and that is the range range multiplied by the value rather. Next, we're going to use describe, and this is basically just taking all the values from the range and the value and the total. It's just adding up between all the ranges and the values. So we get the mean, the standard deviation, the min value, 25th percentile, 50th percentile, all that stuff. And then we're going to use describe once again. As you can see differently, this one does not have the parentheses. And basically what the parentheses does is this takes only the number values inside of our data frame, and it'll show you all the cool calculations for them kind of in a tabular view. However, describe without the parentheses is going to show you a more textual view, and it will show you everything in a textual view of the data frame. So this is just similar to if I were to print out the head. I'll scroll up just a little bit so you can have them both in the screen here. you can see it's kind of just the exact same output, these being the last 5 rows and these being the first 5 rows of our data frame. So next, we're going to take our shape. As you can see, we have 951 rows to only 7 columns. The 7 columns being here. And as you can see, 951 rows kind of says at the bottom of the describe as well. And finally, we're going to show you the data type of every single column or series inside of our pandas data frame. So you can see most of them are stored as objects other than the float values, because the range and the value were both of float when we multiply it together, giving the total a float value. And then next, we're going to want to show the describe method once again, and we're going to show the statistics for the object columns. So basically the object columns are, in this case, every column other than range, value, and total. So basically, when we did describe with the parentheses beforehand, it only did the float values. I can just scroll up just to show you. So you can see only the range, value, and the total, which were all the float values. But now we're going to say, hey, we want to do the describe, but we only want these object values. So it'll tell you some of the fun stuff about the program. As you can see, we got the count, which is just the number of rows again. Number of machine types, say some are missing some. That's why there's only 939 brands rather than 951. And so on and so forth. Okay, so question number 14. This is when we're going to start changing up our data frame. And we're going to take our ID column and we're just going to want to rename it to my ID. However, this is not a permanent rename, and I will show you down below. You can see we're just renaming it, and when we're outputting it, you can see ID is now changed to my ID. This first string right here actually has to be the column of the current name, and we have our colon, and then the name of which we want to change it to, in this case, my ID. However, like I said, it is not permanent. So we're going to scroll down, and you can see my dataframe.head once again, and look at that, it's like magic. My ID is now replaced by ID, which was, of course, the go-to or the default column name. Next, we want to rename that column, but I actually want it to be permanent this time. And we're going to be doing that using the inplace command. So basically, inplace is going to cause it to stay there when set to true, and it's going to permanently overwrite that ID column to my ID, or once again, whatever you set as the name right there. We're going to showcase the head, and as you can see, my ID is now permanently set to my ID. And we're going to scroll down. You can see question 16. I'm just going to show you all the data frame columns now. You can see ID is now replaced permanently with my ID, as that is what inplace does. It will permanently fix that in there. And now for question 17, we just want to rename all of the IDs once again. This is, I know it's kind of a long, ugly way to do it, but basically we're taking my ID, which is, once again, you want to take the current column name. In this case, we just changed it to my ID, and we're changing everything just to an easy lowercase name, easy to read. Once again, inplace true because we want it to be permanent. And I'll show you all the column names. They're all saving. You can see this is what they once were, even up here. Basically, they all go into lowercase. Next, we're going to take the exact same thing. And you know what? Spaces are kind of ugly. We're going to change them into underscores, just to look all nice and readability purposes. And then next, remember those cool columns that we created earlier in our data frame? Brand and total. The brand taking the machine type and the zip code, the total taking the range multiplied by the value. Well, we actually want to kick them out of here. So axis 1 is because it's a header, and so we are dropping inside of our square brackets, since we're doing more than one at a time. We are dropping our brand column and our total column, and inplace equals true once again because we want it to be permanent. And I'm just going to show you our data frame now. We are missing our sweet brand and total series. And further on, what we're going to want to do now is we're going to want to delete a couple rows from our data frame. And as you see here, we have row 3, and we're dropping row 3 and row 5. Axis equals 0 because we're dropping rows, not columns. Rows being the data, columns being like the header. And in place equals true because we want it to be permanent once again. And once again, I'm just showing you the first 5 rows displayed. As you can see, we're missing row 3 and we are missing row 5, letting you know that our drop did actually work and that is no longer stored inside of our data frame variable. Next, we're going to show you a couple of the sort functions inside of pandas. So we're going to take our data frame and we want to sort our values column in ascending order. So there's multiple ways you can actually do this. You can leave it as sort values just like this, and it'll sort in ascending order, or if you type inside of the sort values ascending equals true, it'll also print out in ascending order. However, if you did ascending equals false, it'll start printing out in descending order, but I will show you that later on as we get to it. And so number 22 is just another way to sort the values. However, it's just a little cleaner. You get to see a tabular form with all the data inside of the data frame rather than just the column of our values. And we can scroll down just a little more. As you can see, this is what I was saying. We're going to sort our values once again in ascending order, and we actually want that to stick. We want our values to forever be assorted in ascending order. So we're using in place equals true. It's not just to drop or rename columns. It can be used for all types of things. And I'll show you a little more. Remember when I talked about ascending? Well, this time we want to sort through multiple values inside of our data frame. So we want to sort through our range, and then after our range we want to sort value. And we want our range to be in ascending order while our value is in descending order. And so what we're doing is we're sorting by range in ascending order, and whenever we have a match of ranges, in this case I'll show you 101, we're going to want to sort the value in descending order from highest to lowest, so in this case from 26 to 20. Continuing on, now this is where it gets very cool in my opinion, and you can really have fun with the data frame. We're actually going to take our data frame and we're going to sort the values in between using this. It's really easy to read. That's what I love about Python. It's almost as if you're reading like just straight from a book, or you're just reading like any sentence. It can kind of just automatically compute and make sense in your brain. You don't need that strong of a programming base to understand it. So we're taking our data frame and we're searching inside of our data frame, and we're searching inside of the range column for numbers or values in between 250 and 350. And as you can see, we're just the reason why we actually put this is actually the command highlighted to sort through the range in between those values. However, when we put it inside of the square brackets with MyDF, it actually just prints out for us and just gives you a little visual understanding of what the command actually does. And next on, we want to sort it once again. We want to take all those values in between the range, but we want to sort the values in ascending order, because as you see here, yes, we have all the values, but it's hard to read, it's unorganized. So we're just going to organize it by range, once again in ascending order from lowest value to highest value. Next, we're actually going to take our data frame and we're going to want to display only our ID in our value columns of everything within the range 250 to 350. Once again, I know it kind of looks ugly, but you can use the sort values afterwards if you wanted to sort by the, well, in this case, it sorts by the value, but if you wanted to sort by, say, ID or anything else, you could. You always have that option. And then next, we're taking that same thing, And we're still searching between everything with the range between 250 and 350. However, we're also matching it up with the machine type. So not only does the value of the range need to be between 250 and 350, but the machine type needs to be H. And we're just displaying our ID value and machine type columns. Next, we're going to take our data frame and we want to actually just search for all the rows that machine type contains H, R, or X. So if the machine type is H, R, or X, we're going to display those values. Otherwise, we don't want to see it. We don't care about it. And you can see, we'll just scroll through. Lovely, lovely results there. And finally, coming up to the conclusion, we have command number 30. This one, we're actually going to want to import NumPy as NP. This is the only time we need a library outside of pandas. And we're going to take our data frame and we just want to select all the data types we just want to select specific data types rather inside of our data frame. And we only want those which are of a numerical column. In this case being range and value. Remember when we scrolled up, we don't have them anymore, but we had our range, value, and total columns, and they were all stored as float values, while the rest of the data types were all stored as objects. So what we're doing is we're taking NumPy and we're getting NumPy to say, hey, if this is a number, then we want to show it. And NumPy will do the work for us because it's very cool, very awesome. If we had int, it would show integer values, all that good stuff as well. It wouldn't just take the float values. And then lastly, this is just for proof. I'm just getting the data types of all those data types that we just showed. As you can see, the range is a float value and the value itself is a float value. And I think that concludes my assignment 3 for applied data science. As you can see, there's many cool commands and cool ways that you can play around and edit and really showcase your data from a CSV file. And Pandas is so powerful that really it does most of the work for you. And just knowing a couple basic commands, you can tinker and do as much as you want to the CSV file, making it very cool, very awesome for data learning or anything where you're going to be using Excel files, anything.